Okay, so today we're going to do solving absolute value equations and inequalities. When solving equations that involve absolute value, there are two cases to consider. Case 1, the value inside the absolute value symbol is positive. Case 2, the value inside the absolute value symbol is negative. Okay, so let's look at some examples. Example 1. Solve the absolute value of a minus 4 is equal to 3. What does this mean? That the distance between a and 4 is 3 units. So the distance between a and 4 is 3 units. So we could do this two ways. We're going to first solve it by graphing it. All right, so here's 4. 4 is our number that we're looking at from the absolute value. And we know that it's 3 units is the distance. So 3 units to the right would bring you up to 7, and 3 units to the left would bring you to 1. So therefore the solution set here is 1, 7. So 1, 7 would be the solution set. Now the other way we can solve it is by using those case 1 and case 2. So if case 1, then we take the absolute value symbol off and we say a minus 4 is equal to 3, positive 3. That was our first case. Case 2, a minus 4 is equal to negative 3. That was our second case. Here I would add 4 to both sides, and I would get a equals 7. Here I would also add 4 to both sides, and I would get a equals positive 1. So once again, our solution set is 1, 7. So if you have to graph it, you can graph it. If you want to solve it algebraically through case 1, case 2, you could do that as well. Okay, the second example that we have is to write an equation. Write an equation from the graph. In absolute value form, I'm going to just put absolute value symbols there, from a graph. All right, so here's our graph. And the two numbers that we have on here are 9 and 3. So we need to find that number that is in between the 3 and the 9 and still has the equal distance on both sides of that graph. So that number would be 6. So 6 is 3 away from 3, and 6 is 3 away from 9. So our absolute value equation would be x minus 6 is equal to 3, because 3 represents the distance and 6 represents the number that's on the number line that is equal distance from 6. Okay? Now, number 3 example, we would have the absolute value of t plus 5 is less than 9. Okay, so the absolute value of t plus 5 is less than 9. All right, so we're going to do this in case 1 and case 2. All right, so case 1 and case 2. So case 1 would be t plus 5 is less than 9. All right, now here we're going to say t plus 5, and we know that's going to be a negative 9. But now that we're working with inequalities, not only do we change that to a negative 9, but we also have to flip our symbol. Okay? When you're working with inequalities, you have to flip the symbol and change that second value to its negative. So case 1 and case 2 is a little bit different than when you're solving equations versus inequalities. So now if we solve, we're going to subtract 5 from both sides. So t is going to be less than 4. Okay, here we're going to subtract 5 from each side again, and we're going to get t is greater than negative 14. So if t is greater than negative 14 and t is less than 4, then we have that intersection piece in between. So this is an and, because they are going to intersect. So therefore the solution set for all values of t, negative 14 is going to be less than t, which is going to be less than 4. So you could see this on a number line. If we did negative 14 and 4, it would come in between. So I could just quickly, I'm just going to put down those two numbers. So we would have negative 14 here, and we would have 4 here. Both of them have the open circle, and whatever is in between the intersection of the two, that's how we write down our final solution set. So we would start with negative 14, which has to be less than anything that's in the middle here, which would be represented by t, which is going to be less than 4. All right. We have one last example. I'm going to start another page because it's a... So this is going to be example 4. We have the absolute value of 2x plus 8 is greater than or equal to 6. All right, so case 1 with the positive and case 2 with the negative. So case 1, we're going to say 2x plus 8 is greater than or equal to 6. Now remember, when we have a negative here, so we're going to do 2x plus 8, and we're changing that to a negative 6. Because we're changing it to a negative 6, we have to flip that symbol to represent that as well. All right, so we're going to have, subtract 8 from both sides. We're going to get 2x is greater than negative 2. Divide by 2. X is greater than negative 1. Case 2, we're going to subtract negative 8 from both sides, and we're going to have 2x is less than or equal to negative 14. Divide by 2. X is less than or equal to negative 7. So less than negative 7, this is an OR. This is a union. This is not going to be an intersection. So we can represent that as saying the solution set would be x for all values of x that satisfy the inequalities, that x is less than or equal to negative 7. That's going to go into the left side of your graph. Or x is greater than negative 1. So quickly seeing that in a graph, and once again, I'm only going to put those two numbers on. I would have negative 7 here, and I would have negative 1 here. Less than or equal to negative 7 means it's closed and it would go to the left. Greater than negative 1 is opened and that would go to the right. So that's why this would have or in between.